All right, so let's take a look at number 6. Number 6 is we've moved along from these quadratic inequalities to now rational inequalities. And they've provided the graph, which is very helpful again. But I would make a note here that, let's say note, when we look for what I might call critical values, important values, before those points were, for quadratics, for example, is where the function was equal to 0. Here, we need to find zeros and where the function is undefined. So they've given me one that's in factored form, which is really nice. What I know is that at x equals a positive 1 up here, and at x equals a negative 3, those are my zeros, because that causes me to have a 0 in my numerator. Now look down here in my denominator. At x equals 4, that is where my function is undefined. So there's different ways that we can do this. Mathematically, I could create a number line, and I could break my number line up into pieces and test every piece. And I may actually do that later on. But all of these so far that they've provided has had the graph. And honestly, you guys can graph these and look at the graph to pull out these answers as needed. So what this tells me is essentially my graph, my number line here, is broken up into 3 pieces that I need to look at. So at x equals 1, I have an important point, and that is my x-intercept here, okay? At x equals a negative 3, I have an important point. And that at x equals 4, guys, we have an asymptote. All right, so that's broken up my number line, and I need to, and I could, let's do this. I could put a visual here. It's breaking up my number line into these pieces. Let's see if I can kind of sketch this out. Kind of here, okay? So I need to look and see what's happening between these broken red lines that I've kind of sketched out. And more specifically, I want to look at these pieces and determine where my function is less than or equal to 0. And I'm going to zoom in. Let's see if I can zoom this in a little bit better. Less than or equal to 0. Now remember, you have these on your notes. You can look at this. So what I notice is at this point here, or these points there, my function is below the graph, okay? So, which means my functions are negative, which means they're less than or equal to 0. So from there, how do I define all of these points? That would be from negative infinity to negative 3. And at negative 3, that function is actually equal to 0. And remember that we have the equals to part, right? So it's okay for my function to actually be equal to 0. So I am going to close that bracket. Negative 3 is included. Now between here, I don't really know what the numbers are, but I know all of that is above the x-axis, which means all of those values are positive. Those numbers are not part of this solution. I am looking for numbers less than or equal to 0. Now, I do see another piece that goes below the x-axis, and it is right here. It is that little piece on the other side. I think that is 1. Let me look at my numbers. At x equals 1 was my x-intercept, and everything after that is negative. All right, and so it looks like that goes from 1 to my, I know that went over, I didn't quite go straight, but my vertical asymptote is through there, right? And I know that at that vertical asymptote, there are no points at x equals 4. That's my vertical asymptote. So it looks like from all points that are between positive 1, and I can include positive 1 because at that point that is my 0. But from positive 1 until I reach that vertical asymptote, which is at x equals 4, all of those values are negative. But remember, at 4, I am undefined. At 4, I don't have a point on that graph. That is where that vertical asymptote is. So I can't include 4 in my solution set. So I close that with parentheses. So there, that is how you get your answer. I found my zeros. I find where my function is undefined. And it's as simple as looking at the graph and asking yourself, where is the function positive, where is it negative, and where is it 0?